I believe all of you know what annotations are in Java, right? It's a Java conference, so I think you all know what they are. They appeared in Java many years ago, and I will try to convince you now in the next 40 minutes that they're not such a great idea as some of you may think, and I thought a few years ago. And I will introduce and give you some examples of how we can replace them with something better in order not to do bad things to our code. A few words about myself. I've been working as a software developer and managing software developers for quite a while, about 250 people over the last 5 years actively developing Java code. I have some followers on GitHub, over 1,000, so I'm active contributor to open source projects, and I write code every day myself. I have a certification from Oracle, which is certified Master Enterprise Architect. I have some followers on Twitter. You can also tweet me. I'm on the left top corner is my Twitter account. I tweet about Java and project management, and I have some reputation on Stack Overflow. Just the summary of my credentials. In terms of object-oriented programming and Java, I created a number of products which some people use and some people find useful. First of all, it's a framework, web framework, which was created 2 years ago as a replacement of Spring and Play framework, even though the Spring and Play are quite big, but this one was created as a small alternative and object-oriented alternative. You can check it out, and you will see that this entire web framework contains over 300 classes and not a single static method, not a single getter setter, and not a single use of null references and many other things which I consider are bad ideas in object-oriented programming in general. So that's the framework I created. People use it. It's on GitHub. It's open source, and a team of contributors are there. Another thing which I'm doing is I started to develop a language, a programming language, which is called EOLang, which is going to be an alternative to Java, even though it compiles to Java. So it's like a language which, an experimental language, which is trying to make an attempt to give us the object-oriented way of writing code instead of more procedural way which Java is proposing. And we'll discuss what I mean by procedural when we get to the annotations. And the last one, I wrote a book about object-oriented programming with a focus on Java. It's called Elegant Objects. There are 2 books actually, and maybe some of you are aware of this book. So that's my summary of what I'm doing. And the last one, I just started a few weeks ago, a library which is a replacement for Guava and Apache Commons. You know Guava and Apache Commons, obviously, if you're writing in Java. And again, me and a number of contributors, over 20 people, were not so happy about that libraries because they're very procedural and they are just giving us code without giving us nice objects which we can compose and use them in an object-oriented way. So we started that library. It's called Cactus. You can also try it out. It's still quite young, but already gives you some instruments which you can use for object orientation. So I'm all about object-oriented programming. I believe that Java is not perfect in this area, and I'll show you how and explain why annotations is one of the examples where Java actually sucks in terms of object orientation. So even though they work, even though the code works and compiles, it doesn't look as perfect as it has to be. So enough of the introduction. Let's get to the object-oriented programming. So I believe that in object-oriented programming in Java, in languages which are supposed to be object-oriented, it's all about encapsulation. So we need to always have an object in front of us, and everything which the object responsible for has to be inside the object. So when you touch an object from the outside, everything should happen inside an object. All the functionality, all the calculations, all the thinking, all the brain work should happen inside the object. That's what OOP was invented for, in order to help us group functionality together instead of seeing it everywhere in our code. So in procedural code, we just do what we need to do, where we want it to do, and don't encapsulate anything. So data is available, code is available. It's one large piece of code, one large piece of data accessible from everywhere. Object-oriented programming, in my understanding, suggests us to group things together and call them objects. What happens with annotations, and actually annotations is like the most extreme part, but what getters are giving us and static methods, just two things which I mentioned before annotations, is that they allow our objects to expose their data and make that data available for somebody outside of the object. So what we're doing in Java, in many frameworks which are using getters, for example in Spring or Hibernate, is that an object has some data inside, and then there are many getters in that object which expose that information to the outside, and then somebody else, staying somewhere else, will use that data for some purposes. Like in Hibernate, for example, you have this data transfer object coming from the database, and it has multiple getters, and then somebody else will use that getters to interpret the data outside of the object. The same happens with static methods. You have an object, you give that object to somebody, and then to some static method, and then the functionality inside the static method will take out the data from the object and use that data somehow. So we use objects as just holders of data and nothing else, nothing above that, which is not what objects are supposed to do. They're not supposed to be data holders. They're not supposed to be data transfer objects, just to transfer the data from one place to another and then let static methods to process that data. Instead, they need to do all the work inside, and the data should not escape their borders. So what happens with annotations is that we have an object, we attach an annotation to some part of it, to the method, to the attribute, or maybe to the entire object, and then somebody else from the outside will do some processing of this object using the information from the annotation. That's how annotations work. So you know what annotations are, for example, from dependency injection, or from XML rendering, or from JAX-RS. So different purposes, and all the time it's the same. We annotate our objects in order to give information to somebody outside of it, how to deal with that object, how to deal with the data in most cases, encapsulated in the object. So how it looks like that. So we have an object which holds something, and then we have something outside of an object which does the processing of the internal information. So basically we tear the object apart into two parts, into two pieces. The one piece is the data holder, the container with some data. Another part is some machine, some engine, which knows what to do with the data inside an object. So they always have to go together. So our object is quite dumb and stupid, doesn't know anything about what's happening. And then some smart engine, like Spring Framework, for example, stays outside and knows how to treat our objects, what to do with them. So we have two pieces. Instead of one solid object which knows what's going on, we have two parts now. Quite dumb and simple, and the one we have access to, and then some magic which stays somewhere in the framework which does the job for us using the annotations. The problem is that the maintainability suffers. The maintainability is the key problem. Because of these two pieces, we don't have access to the second piece anymore because it's somewhere in the framework. So we cannot click there and jump in there. We just don't know what works, what happens there. All we see is that our object with just a few annotations, and then we don't know what magic is happening somewhere else. So because of these two places, the maintainability will be a problem. We will not be able to maintain that code because the logic is somewhere else. We don't keep the logic in one place, which we're supposed to do in object-oriented programming. So we want to have objects, solid with the functionality inside. Instead, we have it outside. So what happens in the end is that we start with an object, and then we start annotating it, and the part of the functionality is there in the Spring framework. Another part of the functionality is somewhere else. Another part of the functionality is somewhere else. And an object, finally, looks like a structure which just has something here and there, just some pieces of data. But the real functionality is spread over the entire code base. Something in the framework, something in our code, something somewhere else. So the object just holds a collection of annotations and some data, but we don't know where the functionality is. We don't know where actually the magic is happening. And that's really the maintainability will be the issue eventually. We all know these stories, and with Spring Framework and many other frameworks, when you open the code, you look at it, you see 5 annotations, but if you're not an expert, you just don't know what's going on. You need documentation, you cannot see the code that works. You can only read the documentation. So you cannot click on that annotation and see, okay, this is what Spring is doing for my singleton annotation, for example, or for my, in the JAX-RS for the get annotation. So I cannot click with the mouse and get to that code. And that's what we see, that's what we have, that's going to be the picture of the object. That I think is wrong. It's a problem, even though these annotations, they may look convenient from the beginning. Initially, when you just have one annotation, you just attach it and then boom, magic happens. But on the long run, the code will be less and less maintainable. And now I'll show you a number of examples, practical examples, with a number of frameworks, which we created, which replace annotations with something else. So let's start with a simple one. So this one, do you see? Yeah, this is the code. So in this example, we have a simple Java code, which one method accepts a parameter of type book, and there's an annotation called not null. Who ever used that annotation in your code? That's great. Okay, so you know what it is. So you attach the annotation, it doesn't do anything. So if you just attach it to your code and just compile it, and then pass, instead of the book, you pass null as a parameter, it will just go okay, nothing will happen. So in order this annotation to actually start working, you need to introduce some mechanism. More likely you will use aspect-oriented programming or something like that. So you will need to somehow process your code after compile time. So after you compile it, you need to process it, you need to inject the special pieces of code which will actually validate that the parameters coming in are not null. So there will be 2 pieces. The first piece is your storage class. Another piece of code will stay somewhere and will catch the call to the storage method save and throw an exception if null is passed. So now we have 2 pieces. One piece is the storage, another piece some magic, which is somewhere, which catches the input parameters and throw an exception. It looks kind of okay, maybe, but if you think more, you will realize that that code which you put somewhere, that magic which stays somewhere, is not actually maintainable, and it's not really the way it should be. So this is the code with annotations. This is what I'm suggesting instead. So instead of using not null, in a few libraries of myself, that's what I'm doing. So every time I send a parameter, I wrap the book as a variable, I wrap it in the decorator, which behaves like a book, so it encapsulates the original book, but every time you start touching it, it will throw an exception if the null was encapsulated. So this is more, I believe, more object-oriented approach. There's no magic anymore. We clearly see the code, we clearly see the object of class not null book. It behaves like book, it looks like book, it implements the same interface, but the moment you touch it, you get a null pointer exception or some other exception. If you want to see the magic, you just click the not null book and you jump exactly to the code where the magic happens and you see what's there. So instead of having these 2 pieces and having this object here and then the magic somewhere, we just have them together. That's a simple example. Questions after. Another one, another example of the annotation. This is, again, the simple storage and the simple method save. And then I put the annotation retry on failure. That's the annotation I created in my library called jcabi. You can check it out too. So it works quite efficiently. I made it like 4 years ago when I thought that annotations are actually a good thing. And yeah, and I introduced that library together with an annotation called retry on failure. So how it works, if you call that method, if you just compile it, nothing will happen. It's just an annotation. So the object is still the same. The annotation is just a marker in the byte code. It's nothing else. There's no actual code there. Just a marker saying that this method has an annotation. That's all. And then the jcabi introduces another magic piece, which is called advice. It's using aspect-oriented programming. So advice stays outside of the storage. And every time the call is coming to the method save, it will try to save, and if the exception is thrown, it will try again. It will try again. It will try 3 times. So it's quite useful annotation. Sometimes you, for example, want to save something to the database or send something over the network, and you don't want to fail immediately. You want at least to try a few times. I'm having these situations in all my projects. It's like really common case. So you don't want the input-output exception to happen immediately. That's why the annotation. So I just introduced that. I use it in many projects. It's quite convenient to just annotate the method, run the aspect-oriented programming, so-called weaver, from aspect J, and then boom, you have this method. The method becomes more powerful. So every time you call the method, it tries 3 times. You can configure it, so the annotation is configurable. You can put some parameters there and say try 5 times, or make a delay between retries, or there are some parameters. You can try it yourself. This is with the annotation. And that was 4 years ago, and I've been using it for years. But now I think it's not a good idea, because like I said, the magic is somewhere. So if I show you that code, if I show this code to myself, I don't know how to find that code that tries 3 times. Where is it? So where do I click? Well, I know because I created it, but still for me it takes a few minutes or sometimes half an hour to open that library, to find that place, and then understand what's going on there. So I need to investigate a little bit. But I'm the author, so I know how it was designed. If you try the same, it will take you maybe half a day to find actually where is this magic located. So where is this cycle that tries 3 times? And it's not, well, it does something else. It tries, it makes delays, it logs something, it reports to the log system. So if you want to modify that, you will have a hard time because it's not obvious where this magic is located. That's a different approach, which we introduced 2 weeks ago in our new library, which I mentioned before. It's called Cactus. So it looks like this. You also have this storage, and you also have the method save, and you also want that save method to run 3 times. So we created a class called retry function, which does exactly the same, but is a decorator of a function. So it's like kind of lambda function from Java 8, quite simple. It does what it does, and then the retry function decorates it, and when you call it, it's going to do exactly the same cycle. But now the code is in front of me. So now I can click the retry function and jump right there to the cycle, which does this, repetition and does this retry loop. In the previous example, I don't know where to click. There's no place to click because it's just a marker. It's not about functionality, it's just a marker. Here, it is exactly the functionality right there. I want to modify it, I want to become a contributor, I'm not happy with that, I just click it, I do it. Maintainability is very high, I can maintain that code. In the previous example, the annotation made my code unmaintainable. It just either works or it doesn't work. It's difficult to maintain. Here it's way easier because it's right in front of you. Retry func, click it, you will get into the code, you will see what it does. I think it's important. Another example from, again, same library called jcabi, again my annotation which I created 4 years ago called cacheable. So you put the annotation to the method find and you annotate it with the cacheable and you say forever means true, and then from now on every time we call that method it's going to be cached. The first call will calculate the result, will return something, and if you call it again the second time it will return exactly the same. It's quite convenient. Sometimes you don't need to run it again and again. If you go to the database, it's just the first time is enough. So you just attach the annotation cacheable, and it just works. So it's quite primitive in-memory cache. If you need something more complicated, you can use Guava cache. You can use, there's so many Java cache solutions. But that one is really primitive, simple, and it works. For most cases, it works. Just attach cacheable, compile it, and attach the aspect J advices. There are pieces of advices. So there is the annotation and there is some magic somewhere. So we have 2 places where the code is located. The first place is in front of you. The second one is, I don't even know where. Well, I can remember because I wrote it 5 years ago, 4 years ago. But now it will take me some time to find it. For you, it will take half a day. So the code is not maintainable. This is the alternative, which Again, we made possible in the library just a few weeks ago. We created a function, that's the code, we call it sticky function. So it's sticky because you just touch it once and it kind of becomes sticky, so you return exactly the same. So it works like a cache. And this is the redesign of the storage class. So take a look. The point is that there's no annotations anymore. Maybe you don't need to like really understand the code, but it's quite easy. So the point is that this sticky function is right in front of us. We can click on that and we'll see the code there. So we'll see how that cache works. With the annotations before, it was not clear. Now it's clear. Now the sticky function is the cache. You click there, you see how it works, you want to modify, maintain, you can do it. And it does exactly the same. So the main function is fine, the main method is fine, it calls this cache. The cache goes to the internal method find by ID. It has to be private, I didn't write it. So find by ID is a private one, it calculates, returns, and when you call it again, it's not going to calculate it again, because the sticky function will just get the value from the cache. Exactly the same functionality, but done very much more convenient, I believe. Another example, I have two more examples. Another example, or three more, is the famous XML element. It's about serialization of an object, making it, converting it to XML. So what we do, it's in Java since, I don't know, many years, this API. So you annotate, in the book, you annotate one piece, one attribute, or one getter, it doesn't matter, you annotate with XML element, and then you have the marshaller, so-called, and then you call marshal, and you get the content, you get the XML document from your object. Again, the question is, how exactly it's going to happen? So how will that marshaller take our data out of us, take our data and use them somehow to build the XML document? So we have two places where it's happening. In the first place, it's our object which just holds the data and doesn't have any idea of how XML is built. And then we have another piece, another engine, another magic, which is called marshaller, which builds everything for us, taking data out of us, retrieving the data. I don't think it's good because, as you can see, the object is quite dumb. It only holds the data, having no idea how serialization is happening. Some people say it's good that we don't know that, but I believe it's not good for maintainability. So I hear quite often the argument that this is what we wanted. This is what we wanted to achieve, to just let us write less code and make that code less complex, and let's use the annotation. So let's move the complex parts, what's difficult to understand, let's move that magic somewhere to frameworks and make our objects simple, plain, just holding data. It is true for junior programmers, I think. It is not true for senior programmers, for people who want actually to maintain the system, not just to make it work and not touch it anymore. So if you want to work actively with the system, we need to understand how it works. We need to feel it, we need to touch it, we need to be able to change it and modify it. Here we can't, well, it's difficult to modify. Everything is in the marshaller, and we don't even know when exactly the data will be pulled out of us. I'm suggesting I created, it's just an example, I created a library called assembly for building XML documents in a quite simple, imperative way. So you can also try it out. It makes it possible to build an XML document instead of using these marshallers who pull the data and build something there. Instead, we are calling the XML builder and injecting the data in there, and then that builder generates the data for us. So quite the reverse method. Not being dumb and shallow and stupid as objects, and then let smart guys as marshallers pull something out from us. But instead, the object is smart enough to call that marshaller, to call that builder, and give the data there, and then ask that builder to generate the XML, and then return the XML. So check it out. It's a library. It's on the market for 3 years at least. It's on GitHub, open source. I'm using it, and some people also use it too. Another example. Are you tired already? Because I am. So I'm also like giving this example just to, not to prove, because I don't think I will be able to convince many of you now, but at least I want you to start thinking about that annotations from a different perspective. So I know many people love them, and I know we welcomed them years ago when they showed up in Java 5, I think, if I'm not wrong. Am I right? Java 5? Yeah? Okay, so they were introduced in Java 5, and we were so happy about that because, first of all, we stopped using XML configuration documents in Spring and many other frameworks. We had XML everywhere. Now they gave us annotations, and we were so happy about that. But I believe that XML is wrong, annotations are no better. They're just making code a little bit less, a little bit more compact, but still doesn't solve the main problem. Still, we have a huge magic somewhere and a little small stupid code which we cannot maintain. So I would suggest not to do that. So look at this example. This is a JAX-RS for RESTful APIs. We have some book resource, which is supposed to be HTTP resource with an entry point, and there's a get annotation tells us that it's a marker for the Jersey or some other JAX-RS framework that when HTTP GET is coming in, you have to call this method index, get the hello world, and return it back. So it is actually kind of an HTTP response page or HTTP resource, which doesn't know anything about HTTP, actually. So all it knows is just, I can return you the hello world, and then because of the get annotation, something, I put the question marks because I don't even know what's going to happen there. Something in the framework, in this big framework, they somehow will find my class. They will somehow find that annotation using the reflection API, I guess, and then they will somehow route the request, the HTTP request, to me. How that will happen is completely out of my control. Well, I can go to XML configuration, maybe. I can go to some configuration files. Maybe I can open some .properties files. I don't know what. I will have to read the documentation and find out how this class will be instantiated, by who, when, and when the method index will be called. So all of that will happen somewhere. And all I can do is just I can sit in front of that class and just expect that this will happen according to my expectations. And then we become experts in Jersey, or experts in SOAP, or experts in Spring. Because some people learn more about that problem, they have more experience, and then they know that, okay, if I put just get annotation there, it's probably not enough. I also need to put consume annotation there, which will tell that I'm ready to consume that kind of resource. And then I can put another annotation called produce, which will tell this JAX-RS that, I'm producing text or I'm producing HTML. How do I know it from here? It's not clear. So how do I find out? It's not clear. How do I know the meaning of this annotation? Also, it's not clear. Yeah? Exactly. So I need to go to the specification, I need to find it out, and then if the implementation of that specification doesn't work according to this specification, then it's another problem. So my point is that it's somewhere. It's not in front of me. Of course, I can learn the documentation, I can read from there, I can rely on this documentation, but there's no place to click where I can see how it's happening. So show me the code, I don't see the code. I cannot find where exactly that Jersey is doing that. So where is the code from Jersey? If it doesn't work, how can I modify it? How can I contribute to Jersey? How can I, it's just some magic, some big monster magic which knows what to do. All I can do is just give some markers and expect this magic to work. I don't find it maintainable. Maybe you guys some of you may like it, but I personally find it less maintainable. Here's what I'm suggesting. I created that framework I mentioned before called takes. It does exactly the same as JAX-RS, technically. But from now this book resource will look differently. It's called book front. I called it book front. It implements so-called take. So this take is like a page. It's like a HTTP resource, which has one method act. So it gets the request and returns the response. So inside it works. It returns the response, the text response, and then you use this instance of class take and give it to FT-CLI, it's front and the command line interface. So this is actually the web server. So this FT-CLI is the web server, is the one who is opening the socket, is listening to the HTTP connection, parsing the connection, and passing that connection and passing that request to the front, to the book front. So it's a clear connection between the web server as a bigger object and my web page, which is a smaller object. If I want to see how it works, I just click the button. I just click it. I just click FT-CLI, and I go deeper, and I see how it's structured, and I know how my HTTP request is coming from the socket down to my text, down to my hello world. So there's no magic anymore. It doesn't stay somewhere. It's right in front of me. So I see this is a bigger thing, and my smaller thing just gets into it and gets encapsulated into a bigger thing. So we have object, or can you remember it? I'll finish soon. So that I think is way better. And here's my last example with the inject. It's also quite possible, quite popular. Inject, it's dependency injection, containers, and you have a book, and then inside the book you have storage, and you need that storage for the book to work. So the book, in order to retrieve the name from a database, has to go to the storage. Storage has to be in the attribute. So we put inject in there, and then we use containers, and then we get the book from the container, and then we call book.name. So the container knows where to find the storage, how to instantiate the storage, and how to inject that storage into the book, and then return the book back to me. So this whole magic is happening in the container, again somewhere else outside of my book. I don't see it, and it's not outside of my book even, because the book doesn't need to know where the storage is coming from. But the process of instantiating the storage is hidden somewhere. So I don't know, I don't see the line of code which does new storage. It's not difficult, it's not easy to find that line, because it's somewhere in the container which does it new storage. I may configure the container, I may configure it with annotations, maybe some XML configuration, something like that, but it's still somewhere in the big piece of code which is not clickable. I cannot see who is touching that inject annotation. So the whole problem with annotations is that it's not clear who is touching them. My object is here, my annotation is there, but then the question is who is touching that annotation, who is looking at it, who is reading it, and I don't know. It's maybe somewhere, maybe somebody in the code, maybe many places. They all may be looking at my annotation because it's public, it's visible. Through reflection API, you can get access to it. And this is the problem for maintainability, because I cannot see that links. So my suggestion is that don't use dependency injection containers. They are, I think in general, is a bad idea. So it's better to just inject your dependencies through the constructor, and always make sure that when you instantiate an object, pass everything you need to pass through the constructor. So dependency injection containers, they rotate, they put the situation upside down. You don't see anymore the movement of object instantiation. You lose the control of your objects. Now you don't have object-oriented programming anymore. You just have pieces of code. Okay, the final one. And then we have questions. Singleton. So yeah, that's the final one. So we may put singleton annotation for the object, and then we go to the container and say, get me the storage, and of course the container will return you the same storage again and again, because it's going to be the same object because of the annotation. So the container will know that when there's singleton annotation, you don't need to make multiple instances of it. Is it convenient? Yes, it is. What's the solution? I guess that's the solution. So don't use singletons. Just don't use them. So they're just in general bad ideas. So if you use singletons, if you have singletons in your code, that's a different subject, but I have to say it. So singletons are in general is a bad idea because they are nothing more than global variables. So singleton and global variable, it's exactly the same. So Java was introduced as a language without global variables because global variables are evil, and then we introduced singletons because we don't know how to use objects. So if you use singletons, you're using exactly what C++ and C and Pascal and other languages had before, global variables. And global variables are pure evil because it's clear why, right? Because the entire code base becomes dependent on one thing which is global. So it's difficult to test, It's difficult to make that code scalable. It's difficult to extend it. Everything becomes difficult because your entire code base becomes dependent on something global. And Java is all about not global. So we always want to do new objects, always work with objects, not global things. That's why singletons are bad. Static methods are no good as well. Because, well, singletons are only available because we have static methods. Remove static methods, you will not be able to have singletons at all. So we only have singletons because we have static methods. So static methods are the core root of the problem. Because of static methods, we make our code dependent on global things, and then we're just getting out from all object-oriented programming and getting back to procedural, to C code in Java syntax. So this is my last slide. So that's how it should be. We need to move all the pieces into the object. You remember the previous one? It was like they were taken away from the object. The object got nothing else but data, and all the functionality stayed somewhere else. In the dependency container, in dependency injection container, in that aspect, in the marshalling framework, in the JAX-RS framework. They're all pieces of code located somewhere else. We need to move it into the object back. And the object has to have full power to manage that functionality. That's how it should look. Everything should stay inside the object. The object may use other objects internally, like I showed you the example with the assembly framework. So you can generate XML inside by getting access to some big piece of functionality, to the framework, to the engine, doesn't matter. But the entry point is only one. I only enter the object from one way. So I talk to the object, I don't need to know about anything else which stays outside. And annotations are provoking us to tear the object into parts. And this is the link, this is the last slide. This is the link to the article I wrote about that a year and a half ago. You can check it out. I kind of now summarized what the article said and again gave you some practical examples. So that's it. If you have questions, I'm ready, I guess. There was a question over there. No? So I convinced you, right? Mm-hmm.
And then you have these AOP-like attributes as you are aiming against here. Do you see any difference between these?
Well, I would say there are even more types of annotations. So if I start like from full scale of what they are, there's one type which I didn't mention today, and I have to say they are compile time annotations. So they are okay. So the annotations which stay in the code, like override, for example. You annotate the method with the override, and then the compiler will fail if the method doesn't override anything from the interface. So that's a perfect annotation. Or deprecated, for example. So you put the deprecated on the method, and then the compiler will throw a warning, and that will give you some information that you're doing something wrong. So compile time annotations are perfectly okay, because they're just markers for the compiler. That's all right. And even if you know the library Lombok, probably you know that. So that's, yeah, some people use it, or maybe some people write it. So that's the library which I'm using too, and it's quite nice. It's compile time library. It's actually APT, it's using APT mechanism to process the code during the compile time. So when we compile, try it out, lombok.org. So when you compile it, you annotate your class. For example, you can put on the class, you can put an annotation on top of the class and say it's called equals and hash code. And it will, during the compile time, it will inject equals method and hash code method into your class. You don't need to write it yourself. It will just build it for you. It's quite useful. It has nothing to do with what I said here with the annotations, because it doesn't bring that code into your, well, it does actually. It does, so maybe I'm wrong. Maybe that kind of annotation is also not perfect, not so perfect, because you don't see the code. Huh? You can debug. I would say they're wrong, yeah. I was just saying this is okay, but now I realize this is wrong as well. Because I don't see the code. I can see the annotations, equals, and hash code. I cannot click there. It only will happen, it will bring me some code from Lombok into my code somehow. So I cannot see what's going on inside. It's also not good. So what's good is the annotations for compilers. So the information for compilers, that's all right. But it's just a few of them. Deprecated, override, Maybe what else? We don't have anything else. So, and then you ask about different types of annotations for runtime things, right? So runtime annotations, they could be different. But I think in all of them, in all cases, because annotations don't bring any code together with them, and not even links to the code, all they have is just markers, meaning that the marker is going to be read, is going to be treated, interpreted by somebody outside of my object. So I don't know who is that person, or who is that class, or who is that method will be. And that's a problem. So no matter what kind of annotations, no matter what the purpose, it's still a bad idea. So just use objects, just use new objects, decorators, objects. Every time you need to put some extra functionality on top of your object, decorate it with some new class, introduce new classes, not just that way. That's what I think. Yeah. Mm-hmm. Mm-hmm. Yeah, the question is about source generating and what I think about it in general. Well, I don't use it at all, so I'll just give my opinion, not practical, but just theoretical. So I don't use code generation. Well, I use it for when I'm using Antler 4, you know, this library for syntax analysis. Who's using Antler? Okay, you know what it is. So it's a library where you define your syntax, and then it compiles that syntax into Java code. Well, the Java code, which is not readable at all, it's going to be a huge monster class with 5,000 lines of code, which you cannot read at all. Well, you can if you just look in a few lines, but you cannot. It's unreadable. It's not for a human. It's for a computer, and I don't find it. Well, we have to use it. There is no other way, I guess, because it generates actually the code. It builds the code. But is it a maintainable thing? It doesn't look really maintainable for me. I always have problems with this. Even though I use this library, but I always find it like difficult to debug or difficult to. And there are some tools which help us to debug this syntax trees, and there are some plugins for IntelliJ which will help you somehow. But in general, it's kind of difficult. That's my experience. So if you can stay away from code generation, do it. That's what I would say. So just make sure that the code is right there in front of you. Like I can go through class to class down to the lower level all the time. That's my take. I mean, not an expert. That's all my experience is Antler. That's it.
Can you go back to that?
This? Uh-huh. This one. Yeah.
You say that FT client is actually the server.
Yeah. Exactly.
And it works regardless if you deploy it on a Tomcat or.
We don't need a Tomcat. You just call exec, this one, file the method exec, and the exec opens the socket and starts listening on port 80. How do what? If you want security, you have another class which you decorate your book front with the security decorator, which understands HTTPS. That's how we do it. Yeah, and then you create a few classes, like this one we'll call bookfront, for example, bookfront JSON, and then you introduce bookfront XML, and they will produce different things, and then you combine, and then you wrap them together with the dispatching object, which accepts. Well, in my case, it's easier this way. I was using Jersey for at least 4 years, like creating projects using Jersey, and then I decided this is the way better way, and now all my projects are using this approach. That's my personal, yeah. Mm-hmm.
Same approach. So you can convert annotation to old line to old
can I, in that DSL, can I jump with the mouse click to the code which does HTTP processing? No, registering is one thing, but registering will just put me into some configuration map, right? So when you say no, it's not registering. I'm encapsulating my book front inside my server. So it's not like I'm telling the server, okay, now put it in the configuration that the book will work, and then somehow it will work. I'm just looking at the server now. So the server is expecting one parameter in order to. I'm just telling the server, send all requests here, and not just send it and then okay run and then do something. I mean somewhere where I cannot see it. But it's not. The jersey, what you're saying, if I'm getting it wrong, is that there's some configuration place where I can inject my data and configuration parameters, like run this book resource, use the HTTPS, use the port number, so I kind of configure it. And then I say run it. And then the big magic starts.
You see the code, of course it's clickable. And this is the real code. Just a programmatic approach. Annotation is just, think of it as a facade on top of Jersey. The real engine under the Jersey.
Yeah, I think I understand. I think maybe, I get it. We'll have a way longer discussion, but I get it, but I disagree. Let's put it this way. So I agree that it's better than annotations. But I don't see how much better it is, because it's better because you see the code which actually configures this jersey, because with the annotations you don't see anything. Here you see how you configure it, but you still don't see how HTTP request is processed. I can.
Again, you see the actual code. I think the cells there, they go to one.
Okay, I'll try it out. I haven't seen that. Okay. We just run out of time. Thank you very much.